Okay, let's think back to my original 11 die rolls. One of the things that may have caught you off guard was the fact that I didn't have any 4s or 6s. Just like right now, there's no 1s, nor are there 3s here. What I've done in the next couple sheets of Excel is keep track of any time that result happens, or an even more surprising result. Like, for example, having 2 zeros here is surprising. Having 3 zeros there would be even more surprising, because what that means, if we have 11 dice, if I have zeros in any places, that means we have to make up the difference in clumps of other numbers. For example, there's some clumps of 5s and 6s here. If we have another 0 up here, say there were no 2s, that would still have to be somewhere in the column. So I've had Excel track. Let's take a look over here, how often we get gaps. So right now, currently, there is a gap because there are 2 zeros there. I'm going to press F9 and roll again. Okay, right now, none. No gaps here. No gaps. Let's roll again. No gaps there. Not a gap. There's a 0, but I'm defining a gap to be 2 or more zeros. Now, this is important, and I want to take a small aside here. I've decided to define the gap to be 2 or more zeros because that's what happened in my experiment. And I'm trying to measure to see how often that actually happens. Hopefully that makes sense. When you're reading statistical journals, you have to make sure you know how they're defining the variable they're measuring. And another quick aside, coffee, for example. This is the one I always use. Coffee. Is coffee good for you, or is coffee bad for you? It's a trick question. Coffee itself is not good or bad for anybody. It's A, what coffee is being used for, and B, what is being measured with respect to the coffee. Coffee, for example, could be fantastic for an alternative to ADHD medication, but it could also be terrible for somebody who's hypertensive. So the idea is you can't look at statistical journals superficially. You have to define variables very well and understand what those variables are. Okay, back to this. I'm going to randomize a couple more times. No gaps there, no gaps there. Okay, there's a gap there. So what's kind of fun about Monte Carlo simulations is I can just hold down this button and let her just go to town. This is a little bit hard to look at maybe on your computer monitors, but it's keeping track of how many gaps we're getting over the course of however many trials are being held. And you can see right here the no's and the yeses are bouncing around quite a bit. I'm just going to let go here. So we've had 105 cumulative gaps. I want to ask a question you can't answer. Is that a lot, or is that not a lot? I'm going to have you answer that question in your homework. Write down a thought right now. Is 105 a lot, or is it not a lot? Or do you find it hard to answer based on lack of other information? Write down your answer right now. Write down your answer right now, and then we'll go further. Okay, hopefully you've got your answer written down. The big thing is you really can't metric what 105 looks like until you actually look at how many trials occurred. I was holding it down for a while. That box right there, total number of trials, tells us how many times I have thrown 11 dice. This 116 is a measure of how many times we saw gaps. Like right now, there's no gap. Right now, there's no gap. Right now, there's no gap, no gap, no gap, no gap, no. There's a big string of no gaps right here, which is very, very interesting because if you look at the 116 and the 777, there's actually perhaps maybe a larger percentage than you would expect of gaps. So I just pressed F9 a bunch of times and didn't get any results that had gaps. However, what this tells us is 15% of the time we should get gaps. There's one there. So you can see I just pressed it about 8 or 9 more times. There's 10 times, there's 11 times, there's 12 times. I'm getting lots of runs without gaps. As a matter of fact, quote unquote, more than I quote unquote should. because it happens 15% of the time. But here's the real big takeaway about this number, 15%. See how it says percent of the time? When you talk about 15% of the time you're getting gaps, that does not mean that 1 out of every 7 times you're going to get gaps. This is not a promise of every 7 times you're going to get one with a gap. It means of all the trials we've seen, we've had 15% that resulted in gaps. So you can press it 7 times. 1, 2, 3, 4, 5, 6, 7. I got 1 in 7 that time. 1, 2, 3, 4, 5, 6, 7. I got none out of 7 that time. 1, 2, 3, 4, 5, 6, 7. I got 3 out of 7 that time. You see what's happening? I got 1 out of 7, then I got 3 out of 7, and I got none out of 7. Only one of those was exactly 15%. 1, 2, 3, 4, 5, 6, 7. That was 2 out of 7. Only one of those 4 results was exactly 15%. This is averaging the rate over a long period of time. That's a very important point to kind of commit to memory right now about randomness. It's impossible to predict on the next trial with certainty what is going to happen. For example, if you asked me if the next trial was going to have gaps, I would bet no, because 15% is still a small percent. I'm going to guess no. Oh, and look at that. I was right that time. What randomness can have is an underlying behavior that becomes obvious with more and more and more trials. So the more I hold down this F9 button, the better the data I'm getting. And just so you know, this data over here is not stabilized. Those percentages are changing. They're just not changing a whole lot at this point. The big takeaway here is, if you were surprised when I rolled my original 11 dice and got 2 numbers not show up, no 6s and no 4s, what this tells you is there was a pretty decent chance that that was going to happen. But the thing about it is, the only way you realize that underlying percentage is by running a whole lot of trials. That is what is often missing from media reports. A lot of times they focus only on the total cumulative, which is impossible to measure unless you can compare it to something and get a, once again, per capita. And even kind of more importantly, surprising results happen on the small scale. We saw one earlier when I had 9 1s out of 11 rolls. Those are surprising random results. That can happen. The best way to look at these results is to make sure you define your variable well, and when you're talking about the occurrence of something, make sure you measure the results against the totals. That's the only way you're going to get an accurate look at what's actually going along. Now, you might take issue with the fact that I defined a gap as 2 or more. That's totally fine. That is completely and totally fine. You don't have to define it as 2 or more. You could define it as exactly 2, or 3 or more, or 5 or more, or any number of ways. I chose 2 or more because 2 happened to me, and in my heart of hearts, if I had seen even more gaps, like 3 or 4 or 5, that would have also surprised me even more so. So I decided to loop them all together. So I think we've kind of put to bed the worry about those gaps that you may have been concerned about before, because gaps happen fairly frequently. As a matter of fact, there's something pretty cool about how often these gaps happen, roughly 15 to 16% of the time. Let's go back to Max's die rolls and then see how they compare to all the die rolls I've been collecting in the background this whole time. Let's take a look.